Welcome back to College Algebra. In this lecture video, we are going to finish up our lecture video series 4.3. So the very last objective here is about the ultimate way to find all the zeros. So the ultimate way is basically a combination of doing certain things by hand and with the aid of calculator, okay, to help us to find all the type of zeros. So just refresh your memory, the different types of zero we have non-real zeros, irrational zeros, and we also have rational zero theorem. So remember what I wrote before, real zeros consists of irrationals and the rational zeros. What that means is you will see those type of zeros on the graphing calculator. So the first thing we're going to do is use our rational zero theorem to do the P over Q to list all the possible rational zeros, because in that case, if one of my zero is going to be a fraction zeros, the P over Q can help us to identify who that might be. And then we're going to graph the function to see which zero that we listed from step number 1 is our actual zeros. Then we're going to use the zero we found to perform the synthetic division. So the purpose of synthetic division, when we introduced it in other video, was to knock the exponent down, okay, to a quadratic. That means once I'm down to a quadratic, I can use the quadratic formula, okay, or other technique of solving quadratic equation to help me to find the other zero. So for example, okay, so here's my function g sub x equal to x to the 4th, and so on. So first thing, before we even do the P over Q, have an idea what this function will look like, so when we graph it we won't be so surprised. Degree is even, leading coefficient is 1, so the right side, scribble, the right side goes up, the left side will go up. Okay, so the zeros will occur where the scribble part is going to be around the x-axis. Alright, so let's do our P over Q. So if I do my P over Q thing, the P are the factors of my constant term, the Q is going to be my leading coefficient. So what times what is 8? 1 times 8 and 2 times 4. So these are the factors of my P over my Q is going to be 1, so that will only be 1 times 1. So when we write out our P over Q, you can clearly see all my rational zeros is going to be integers. So I'm going to have a positive ones, so am I going to have the negative ones. So there'll be 1, 2, 4, 8. Positive and negative. So that means what I'm going to look in a minute here is from negative 8 to positive 8. That's where my rational zeros will occur at. Alright, step number 2, let's graph this function into our calculator to see which one of these 8 is going to be my actual zeros. So remember now, the left side and the right side will both go up. Okay, they'll be right here. So just by looking at the graphing calculator, it appears that I only went over the x-axis. I crossed over the x-axis twice. So my multiplicities are 1 and 1. Alright, so use my I'm gonna use the table, look between negative 8 to 8. So right away I see 1 equal to 0, 2 equal to 0. So I have 2 zeros so far out of the 4 I should have. Okay. So what are the other 2 missing zeros? The other 2 missing zero is not showing up on the graphing calculator. So that means those 2 got to be the irrational zeros. Excuse me, the non-real zeros. because the non-real zeros come in conjugated pairs, meaning one is positive, one is negative. Alright, so I kind of know that already before I even continue. Step number 3, use the zeros that I just found to perform my synthetic divisions. Alright, so there is no missing term, so that will be 1, negative 3, 6, negative 12, and 8. I'm going to use 1 to start out with. So by the remainder theorem, since 1 is my 0, my remainder will be 0 as well. Bring down the 1. 1 times 1 is 1. Synthetic division, we will add. That's negative 2. 1 times negative 2 is negative 2. This add up will be 4. This is going to be 4. 1 times 4 is 4. Add them up will be negative 8. 1 times negative 8 is negative 8. Add them up, that will be 0. So my remainder is 0. So now, went through the synthetic division one time, my exponent started with 4, now will be 1x to the third. So do it one more time using the other 0 to knock my exponent down to a square. I'm going to do it right here. So this is 1, negative 2, 4, negative 8. Alright, bring down the 1. 1 times 2 is 2. Add them up is 0. 2 times 0 is 0. Add them up is 4. 2 times 4 is 8. Add them up will be 0. So now, this my leading coefficient 1 representing 1x to the second power plus 0x plus 4 equal to 0. So now solve for my quadratic equation. This quadratic equation only consists of 2 terms, so I'm going to move my positive 4 over, and that will leave me with x squared equal to negative 4. So now when I take a square root on both sides, my answer got to be positive and negative 2i. Okay, so what are my zeros? 1, 2, negative 2i, and positive 2i. These are my 4 zeros. Okay. Alright, why don't I pick an example? Well, you know what? I'm just going to do some of these. Okay, this one is kind of big. This 128 back here is kind of large. So let's try another one. Follow my 4-step. Let's do our P over Q thing. Now remember, now the purpose of P over Q is to see if I'm going to have a fraction 0, potentially. Okay? Potentially, after I graph it. So my Q is the leading coefficient, which is going to be 1 times 1. So that means when my denominator is 1 here, all my rational 0 is going to be integers. Okay? So I can go through this, it's no problem. What times what is 128? Let's just give it a try. 1 times 128, that's obvious. 128 divided by 2. 2 times 64. Alright. 3 cannot go to 128. 4 can. That would be 32. 5 cannot go into 128. 6 cannot go into it. 7. Let's try with 7. I don't know if 7 can. I'm going to try it though. Nope. 8. Definitely. 8 times 16. Alright. 9 cannot. 10 cannot. 11. I don't think so. 12. No. 13, 14. 14, I'm going to try 14. Nope. 15, no. 16 I already got, so this is the end of it. Okay. So, my factor of P will be 1, 2, 4, 8, 16, 32, 64, 128. So that means my P over Q, what I will be looking at (32, 64, 128). So what I will be looking at is actually go from positive to negative 128. All right, let's graph it. So again, h to the fourth power, it will look something like the previous one. Right side goes up, left side goes down. So what I'm really trying to look at here is how many times does my function cross over the x-axis or turn at the x-axis? Plus ax squared minus 32 minus 128. One time, two times. Okay, so once that thing goes up, by the leading term theorem, it's not going to curve back down somewhere way beyond my window range. It's going to curve back towards the x-axis. Alright, use the table to see which zero. Negative 2 and 4 right off the bat. So since I only see it cross over the x-axis 2 times, that means the other 2 zeros got to be the non-real zero, just like the previous problem. Alright, so go through our synthetic division to knock my exponent down to a x squared. So my coefficient are 1, negative 2, 8, negative 32, and negative 128. Alright, I'm going to use positive 4 first. I'll bring down the 1, that's 4, add them up, 2, that's 8, add them up, 16, 16 times 4, 64, that will be 32, 4 times 32 is positive 128, remainder is 0, so this is 1x to the third now. So now, move down a little bit. I actually don't need that. What am I doing? Alright, I'm going to use the other one. So continue. 1, 2, 16, 32. Using my negative 2. Bring down the 1, negative 2, add them on 0, that's 0, 16. Multiply them will be negative 32, add them up, my remainder is 0. So this leading coefficient 1 actually represent 1x to the second power plus 16 equal to 0. Alright, again, just like the previous problem, move my positive 16 over, that will be x squared equal to negative 16. Take a square root on both sides. My answer, positive and negative 4i. Alright, so my zeros are 4, negative 2, there's a comma right there, negative 4i, and positive 4i. 2 real, 2 non-real. Because I only see 2 real ones cross over the x-axis. Alright, let's try this one. Again, when I do my P over Q thing, the leading coefficient is going to be 1. So I know all my zeros is going to be integer. So for this example, I'm going to skip over step number 1 because I kind of already did it just by looking at it, just by thinking about the P over the Q. So this time, I think the right side goes up by the leading term test, left side goes down. So this is what I'm expect to see. So ideally, I should have 3 zeros. Let's see how many times it cross over the x-axis. 1. Oh, that is not a cross right there. Let's see what that number is. That number is 1. Negative 2, 1. Think about this. So from step number 2, negative 2 and 1. I'm going to take a picture of this, okay? This is interesting. because I should have 3 zeros. I should have 3 zeros here. This point, this 0 is 1. It crosses over at -2. So that's 2 zeros out of the 3 I'm supposed to have. So where is my missing one? The one that's missing cannot be the non-real, because non-real come in what? Conjugated pairs. Alright. The one missing cannot be irrational zeros either, because irrational zero also come in conjugated pairs. Plus, irrational zeros are real numbers, so that means it will show up on the number line. So what's going on here, by looking at the graph, when my graph go towards the real number 1, it actually turned. So that means the multiplicity, okay, by the even and odd multiplicity, this is multiplicity 2, and this is multiplicity 1, because 2 plus a 1 will add up to be my degree of the polynomial. And I think we mentioned that back in 4.1, the even and odd multiplicity. Alright, so that will be my answer, because I only have, because I'm supposed to have 3 zeros. The only reason why I only end up with 2 is because my real number 1, my 0, 1 has a multiplicity. Let me type it out. So sometimes I type it. My multiplicity for my 0, 1 is actually 2. It's even multiplicity, and -2 is 1. So that's why the 2 add up together give me x to the third. So not every problem we have to go through all 4 steps. Okay, not every problem we got to go through all that. All right. Why don't I show y'all an example? Okay, where the leading coefficient is not 1. So this one, find the zeros. So this particular example, I got to do the P over Q, because I know my Q is the factors of the leading coefficient. What times what is 10? 1 times 10 and 2 times 5. Alright, the factor makes up 24. 1 times 24, 2 times what? 12. We'll put it back here. 3 times 8 and 4 times 6. Okay, so all these are my factors of the top. These are the factors of my Q. So let's do the P over Q. Alright, so if I do all these numbers on top over 1, I should have 1, 2, 3, excuse me, 4, 6, 8, 12, and 24. Again, this is all going to be positive and negative ones. 1 over 2, 1/2. 1 over 5, 1 over 5. 1 over 10, 1 over 10. 2 over 2 is 1. 2 over 5 is 2/5. 2 over 10. 2 over 10 is 1/5. I already got it. 3 over 1. 3 over 2 is 3 over 2. 3 over 5 is 3 over 5. 3 over 10 is 3 over 10. Ooh, this is a lot of them. Alright. 4 over 1 is 4. I already got it. 4 over 2 is 2. 4 over 5 is 4 over 5. 4 over 10. What's 4 over 10 reduced by 2? 2 over 5. I already got it. Okay. 6 over 1 is 6. 6 over 2 is 3. Got it. 6 over 5 is 6 over 5. What's 6 over 10? Reduced by 2, that's 3 over 5, which I already got it. Okay, a over 1, a over 2, a over 5. I don't have an a over 5 yet. A over 10. What's a over 10? Reduced. 4 over 5. Already got it. Alright, 12. 12 over 2. 12 over 5. I don't have 12 over 5 yet. 12 over 10 reduced. 6 over 5. Already got it. Okay. 24, 12, 24 over 5. I don't have 24 over 5 yet. 24 over 10 is 12 over 5, I think. Yep. Alright, so here are all my positive and negative ones. Alright, a lot of fractions to choose from. Remember now, all these numbers you see times by 2 because there's a positive and a negative. Okay. Alright. So, what is one big thing I messed up on at the very beginning? This problem. We gotta scratch all this. Okay. I just saw it because it's hard to see. That's 10x squared. The degree is 3. The degree is 3. So that tells me that this term should be the first term. This, oh Lord, what happened? Oh man, shoot. Oh Lord, Mr. Chan. You know what? Let me just scratch this out. There you go. This should be the first term. So the denominator is not 1, 2, 5, 10. It's only 1 times 3. So when I do my P over Q thing, what's that number 1? See? When we saw that as an x squared, we can't use that. Got to use the degree of the polynomial. So now it's still going to be 1, 2, 3, 4, 6, 8, 12, and 24. Alright. 1/3 is 1/3. 2/3 is 2/3. 3 over 1, 3 over 3. 4 over 1 is 4. 4 over 3 is 4 over 3. 6 over 1 is 6. I already got it. 6 over 3 is 2. Got it. A over 1 is 8. A over 3 is A over 3. Alright. 12 over 1, 12 over 3. I already got them. So that's it. Positive and negative ones. Okay. Alright. Number 2. Let's graph this function. This is x to the third, but it's a negative coefficient. Negative x to the third plus 10x squared plus 44x, then plus 24. So this type is left side up, right side down by the leading term test. Let's go up, let's go down. One more. Did I do it right? Negative to the third, 10x squared plus 44x squared plus 44x plus 24. Yeah. That's weird. Am I typing it right? Let me clean that up. Because it's not, I'm not seeing what I want to see. Negative x to the third. No, negative 3x to the third. Plus 10x squared. Plus 44x. Then plus 24. There we go. There it goes. Left side up, right side down. Alright. So it crossed over the x-axis 3 times. So I got 3 real zeros. So let's see what the calculator shows. I suppose I have 3, and I see 3. So right away I see -2. Alright, let's find more. Looking for... No, these y values are getting bigger as x going more negative. No, don't have anything over there. Look at these y value as x go into positive. Oh, right there, 6. That's 2, missing 1. Missing 1. That's -2. That's 6. I'm missing 1 right here. If you look at it, this is between 0 to -1. Let me show you. By the intermediate value theorem, you see how it go from 0 to -1? The y value changed. So when the y value changed, that tells me that there's a 0 in between. So this 0 in between gotta be one of my negative fraction ones. Which one do I check? Well, I'm not gonna check -4/3 because -4/3 is actually even more negative. I'm looking for anything between 0 and -1. So I will try with -1/3 and -2/3. So second calc, number 1, try -1 divided by 3, which is not a 0. -2 divided by 3, which is a 0. So here are my 3 zeros. Okay. Alright. Alright, I'm gonna try another example. Okay. Let's see. I think the remaining 3 I have. The remaining 3 I have, all the same type. Okay. They're all x to the 3rd, that's what I mean. They're all x to the 3rd. So leading coefficient is all gonna be 1. So I'm gonna have integers for the rational 0. So I'm gonna skip over step number 1 for a moment. Okay. What I want to demonstrate here is to show y'all. Remember now, I just said all the rational 0 will be integers. Okay, there's not going to be any fraction because my q is a 1. Let's check it out. I'm going to graph it and demonstrate to you. Plus 15. Okay, I'm going to graph it. How many times do we see it cross over the x-axis? 1, 2, 3. Very good. See all 3 of them. But if I will go to the table, which one says 0? Which y value is 0? Just 5. Alright, by the intermediate value theorem, you can also help me pinpoint a little bit. See, this is getting bigger and bigger. I'm looking for the different, right here, between 1 and 2, see the y value changing signs. So that means there's a 0 between 1 and 2. It cannot be like a fraction 0, like the previous example, because this one, when we do the p over q, there was no potential fraction zeros. Okay, so what that tells us is the remaining 2 zeros that we see on the graphing calculator got to be the irrational zeros. So let's check it out. Use my syntactic division to break my x to the 3rd down to a x squared. Watch this. Bring down the 1. 5 times 1 is 5. That's a 0. 5 times 0 is 0. That's a -3. 5 times -3 is -15. Add them up. Remainder is 0. So the quadratic equation I end up with is x squared plus 0x minus 3. So this time, if I would move my -3 over, I give myself an x squared equal to positive 3. You know, the other ones was a negative number on this side. So when we take a square root, it becomes I. Not this one though. This one is a positive 3 here. So when I take a square root on both sides, my answer is going to be positive and negative simply square root of 3. There you go. These here are the other two irrational zeros. So my zeros are 5, negative square root of 3, and square root of 3. Okay. Alright, so that's the ultimate way to find all the zeros. Now, in the next lecture video, we're actually going to do this slightly backwards. Lecture video 4.4 is actually a summarize of all these theorems that we've done out of the 4.1, 4.2, and 4.3. We're just going to look at those theorems, apply those theorems in a different way. Okay, so thank you for watching. This is it for the lecture video 4.3.